a production of Kentucky State University Aquaculture.
The outdoor beauty of the United States can be breathtaking. However, during the 20th century, with growing industrialization and the concentration of people in cities, industrial and human waste began to affect our environment, particularly our water supply from rivers and lakes. Technology solutions had to be developed to treat the large amount of waste and produce acceptable effluent that could be returned to the environment with minimum contaminants. In 1977, Congress adopted the Clean Water Act, and today nearly 65% of the U.S. population is served by their own community water treatment plants. Frankfort, the capital city of Kentucky, has a wastewater treatment plant that treats domestic and light industrial waste.
The plant uses an aerobic oxidation ditch process. Wastewater is treated as it flows through these oxidation ditches.
Treated water is disinfected by ozone before releasing an average of 6 million gallons of water per day into the Kentucky River. As the city of Frankfort and Franklin County continues to grow in population, now at over 40,000 residences, old wastewater facilities have been replaced or expanded with state and federal grant assistance and city funds. This is commonplace in other towns that have outgrown their facilities or are required to update their facilities. Many municipalities that have decommissioned old facilities are required to fill in old sedimentation ponds and tanks or demolish them. Such units could have direct applications in the exciting industry of aquaculture or fish farming, specifically for hatcheries to produce a supply of fingerlings for future sale in the marketplace.
There are 3 sustainable resources required for aquaculture that are available here at the Frankfort Wastewater Treatment Plant.
A large volume of effluent water tested daily and meeting the stringent guidelines enforced by the EPA, the Environmental Protection Agency. The second requirement, decommissioned tanks that once were used as digester tanks and are well suited for fish culture. And a third necessity satisfied by the Frankfort Treatment Plant is live food, or Daphnia, sometimes called water fleas, that grow naturally in the clarifier tanks and are acceptable as first food for young fish.
Daphnia growing in these clarifiers are a nuisance because they disturb the settling process.
What's considered a nuisance at some plants is a tasty meal for fish.
Harvesting Daphnia as fish food would help the treatment plant solve the problems of settling in the clarifiers.
One species that has been successfully tested is the paddlefish. Paddlefish are an emerging food fish for 2 reasons: their delicious boneless meat and their black roe or eggs are made into high quality and expensive caviar. Paddlefish are native to the U.S. and are found in 22 states that drain into the Mississippi River, with adjacent drainage into the Gulf of Mexico. Other fish need not fear the paddlefish. It's a filter feeder during most of its life, feeding primarily on zooplankton such as Daphnia, which is the first food of choice for paddlefish fry. How rapidly do paddlefish mature? They are fast-growing at 5 to 10 pounds per year when filter feeding in open water. To test the feasibility of growing paddlefish fingerlings in the Frankfort Wastewater Treatment Plant, 2 300,000-gallon digester tanks and a 30,000-gallon sludge thickener tank were filled with ozone-treated water. Daphnia were collected and transported to the tanks. Paddlefish were introduced into the tanks. Young fish were fed each day until they grew to about 3 inches. At this size, fish are known as Phase 1 fish and require a 30-day growing period. Because the population of Daphnia declines in the late spring or early summer as the water temperature increases, paddlefish are switched to a commercial floating feed to promote rapid growth and reach 12 inches or more within 3 months. This size represents Phase 2 fish. Paddlefish were then harvested from the Frankfort tanks, placed in live tanks, and hoisted to the surface by a crane. Carefully lowered to the ground and temporarily put in a holding tank. Weighed
28.4.
Then placed in a hauling truck and stocked into municipal water supply lakes as permitted by the Kentucky Department of Fish and Wildlife Resources. Later, these fish will be harvested and provide both meat and caviar. Similar facilities at other municipal plants could be used in the production of other food fish and shellfish, such as hybrid striped bass, catfish, baitfish, and shrimp. As the fish population declines in many areas of the world, aquaculture has become a hot topic. One answer to the seafood shortage could be the use of these old facilities to serve as a hub for fingerling production. Fresh seafood produced right in the consumer's own community.